Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Alia binti Arifin. I am from CDCS 250A and today I want to present for our case study Heaven Inn Boutique Hotel Chain. First of all, let me introduce Heaven Inn. It's a boutique hotel chain with one main hotel and two branch hotels. So the network supports online booking, staff operations, CCTV and guest Wi-Fi. However, the current network is slow, insecure and difficult to manage, so a better network solution is needed. The next one, the main hotel acts as headquarters and hosts the central reservation. Both branch hotel depends on the headquarters for daily operations. So currently, all the hotels use consumer grade routers and guest device, staff computers, CCTV and smart devices share the same network. There are several problems with the current networks, so which is guests can access Wi-Fi without authentication and all the devices share the same network, which is creating a security risk. So the internet is slow, branch hotels sometimes lose connection to the booking systems, so network management is difficult and current setup cannot support future expansion. To address this issue, the client requires a network with better performance, reliable connectivity and high availability. So the networks must also provide a strong security, support future expansion and allow a centralized management. So, our project has three objectives. First, to design a reliable and scalable network for all the hotel locations. Second, we want to improve performance using VLANs, QoS and secure connectivity. Finally, we want to enhance security by implementing firewalls, a guest captive portal, access control and network segmentation.
Assalamualaikum, my name is Shalina Omni and now I will present the proposed network design for Heaven Inn. This network topology uses a hierarchical network model consisting of the core layer, distribution layer and access layer. This design is chosen because it provides better performance, security, scalability and easier management compared to the current flat network. The main hotel acts as the central site, hosting important services such as the reservation system, hotel management system, authentication server and network monitoring system. The distribution layer handles inter-VLAN routing, SCL, COS and security policies, while the access layer connects end-user devices such as staff PC, guest Wi-Fi devices, CCTV cameras, printers, IP phones and smart hotel devices. In addition, VLAN segmentation is used to separate guests, staff, CCTV and IoT traffic, which improve both security and network performance.
The next one, this is the logical network diagram for Heaven Inn. So the main hotel acts as headquarters, while branch A and branch B are securely connected using IPsec site-to-site VPN. So all the internet traffic pass through the firewall for security before reaching to the layer 3 switches, which is to perform inter-VLAN routing. So the network is also divided into separate VLANs for management, hotel staff, guest Wi-Fi, CCTV and IoT devices to improve both security and network performance. For this logical network diagram also, we have IP addressing scheme, which is each VLAN at every hotel has its own unique subnet to avoid address conflicts and support future expansion. So the default gateway uses the first usable IP address, which is .1 at the main hotel. The gateway is configured on the layer 3 core switch, while the branch hotels use layer 3 distribution switches. So the network uses private IPv4 addresses and the firewall will perform NAT so our internal devices can securely access the internet. The next one is physical network diagram. So this is our physical network diagram of Heaven Inn. So the main hotel acts as the central network hub and hosting the core infrastructure and centralized servers. Branch Inn A and Branch Inn B are securely connected to the headquarters using IPsec site-to-site VPN. So this diagram also shows the placement of networking equipment and structured cabling to ensure secure and reliable connectivity across all the hotel locations. The networking equipment and transmission media are used at each location. The main hotel contains the firewall, core router, layer 3 core switch and server rack. So each branch hotel includes a firewall, layer 3 distribution switch and layer 2 access switch. For connectivity, we use fiber optic cables for the backbone and Cat6a Ethernet for local devices and PoE Plus to power devices such as wireless access points, CCTV cameras and IP phones. The next one is inter-networking devices. So, this slide shows the main inter-networking devices that use in our purpose network. First, the next generation firewall protects the network by filtering the traffic, performing NAT, and establishing secure IPsec VPN connections between the headquarters and branch hotels. The next one is the core router, which is to manage communication between the headquarters, branch hotels, and the internet while providing high-speed WAN connectivity. The next one is the layer 3 switches to perform inter-VLAN routing and support features such as access control list and quality of service to improve network performance and security. The last one, the layer 2 access switches to connect end-user devices such as computers, wireless access point, CCTV cameras, IP phones, and IoT devices. So they also support PoE+, allowing both power and data to be delivered through a single Ethernet cable.
Let's look at the LAN technology. To solve Heaven-in slow network speed and eliminate data security risks, we completely redesigned the wire infrastructure from the ground up. For our core to distribution backbone, we select high-speed OM3 and OM4 multi-mode fiber optic cables capable of 10 gigabit speeds. This ensures that heavy data traffic traveling to our central booking and billing systems experience near zero delay. From the distribution layer down to the end devices, we utilize category 6A UTP cabling. This delivers reliable gigabit performance to everyday systems like staff workstation, post terminals, and IP cameras. To keep the physical deployment clean and cost-effective, our access switch use IEEE 802.380 PoE plus technology. This allows us to run both power and data to devices like security cameras and wireless access point through a single cable. Finally, to ensure high availability, we implement standard LACP link aggregation. This effectively doubles our bandwidth capacity between switches and provide instant automatic failover if a link goes down. The critical part of this LAN upgrade is network segmentation. As you can see in this table, we have completely discarded the risky, flat network structure where all devices mix together. Instead, we have broken the network into 5 dedicated VLANs. The first one, VLAN 10 for management. The second one, VLAN 20 for hotel staff. The third one, VLAN 30 for guests. VLAN 40 for civilians. And the last one for smart IoT devices. To make sure guest video streaming doesn't slow down hotel operations, we have applied strict quality of service or QoS policies. Staff and central booking traffic on VLAN 20 are placed into strictly priority queue, meaning business transaction always go first. Guest Wi-Fi, on the other hand, uses class-based fare queue with individual per user bandwidth limits. Now, let's look at the Enterprise Remote Access Framework, which is cover how we securely connect our two smaller 20-room branch-ins back to the main hotel headquarters. We implement a software-defined WAN or SD-WAN architecture that builds encrypted IPsec tunnels over ordinary public broadband. To ensure absolute privacy for financial transaction and booking details, all data traversing these tunnels is locked down using enterprise-grade AES 256 encryption and SHA-256 integrity verification. To address the branch hotel's history of losing connection, we deployed dual WAN links at every location, combining fiber lines with high-speed broadband. The SD-WAN appliance intelligently monitor jitter, latency, and packet loss in real time, dynamically routing our critical reservation traffic along the cleanest available path to guarantee a 99.9 uptime. For our remote workers, such as hotel manager, off-site accountants, and on-call IT staff, we provide secure client-to-site SSL TLS VPNs. To log in, user must clear multi-factor authentication. The system also conduct an endpoint posture check to verify that the remote laptop has an active firewall and up-to-date antivirus before granting access to our internal subnet. Next, wireless technology. To eliminate the dead zones of slow Wi-Fi of the old setup, we adopted the modern Wi-Fi 6 standard or IEEE 802.11ax. We optimized our access point to broadcast on the both 2.4 GHz band for long-range coverage and the 5 GHz band for high-density, high-speed media streaming. Instead of configuring dozens of routers one by one, the entire wireless network is governed centrally by a wireless LAN controller or WLC. All access points act as lightweight devices that automatically pull the configurations radio frequencies, and security update from this single pane of glass. This ensures absolute policy consistency. To keep our wireless environment safe, we are deploying a unified triple SSID strategy across the entire hotel chain. First, Heaven in Guest is our visible network. It redirects guests to a secure captive portal where they must accept our term of service and authenticate using their room number and last name. Second, Heaven in Staff is a hidden network dedicated to internal operations. It utilizes WPA3 Enterprise, meaning every staff member logs in with unique credentials linked to a radius server, ensuring total accountability. And the last one is Heaven in Smart Device. It's also hidden, utilizing WA3, SAE and MAC address, filtering to isolate smart locks and thermostats safely away from our corporate data. To deliver a premium user experience, we enable IE 803.11r fast transition and 803.11k. This allows guests and staff to walk seamlessly between rooms, floor and building without experiencing drop connection or annoying re-authentication prompts. Finally, aligning with modern sustainability goals, we have programmed a POA power scheduling profile into our WLC. This feature automatically cuts power to design access point in empty space like conference room and dining halls during late night hours, specifically between 1 a.m. and 6 a.m., significantly reducing the hotel's energy consumption and carbon footprint.
Next is for one service provider and one technology. For one connectivity, Heaven In should subscribe to a business-grade ISP such as DM, Unified Business or Maxis Business. Business packages provide higher bandwidth, better reliability, faster support, static public IP addresses, and SLA guarantees. The main hotel will use a higher bandwidth package because it hosts centralized services, while the branch hotels can use lower bandwidth packages. The proposed one technology is SD1 over business broadband internet. SD1 provides centralized management, intelligent traffic routing, secure IPsec, VPN tunnels, and better scalability for future expansion. Next is network security. The proposed design uses a layered security approach to protect hotel systems, staff resources, guest access, and branch communication. The first mechanism is VLAN segmentation, where separate VLANs are created for management, staff, guest Wi-Fi, CCTV, and IoT devices. This prevents guests from accessing internet hotel systems. Second, a next generation firewall is deployed at the main hotel to provide traffic filtering, intrusion prevention, malware protection, and VPN security. Third, SCLs and WPA3 Enterprise authentication ensure that only authorized users can access internet resources. Finally, a captive portal will control guest internet access, while CCTV and IoT devices are isolated in dedicated VLANs for additional protection. Lastly, for network management, the main hotel acts as the centralized management center for all branches. First, administrators can remotely manage routers, switches, firewalls, access points, and SD1 devices from one location. Second, a network management system such as PRTG or web-based will monitor device health and warn links using SNMP, it allowing faults to be detected early. Third, centralized log management improves troubleshooting and provides better visibility of security events across all hotels. And lastly, configuration backups and automated alerts can enable quick recovery from failures, reducing downtime and keeping hotel management running smoothly.
In conclusion, this new network architecture completely transforms Heaven in digital operations. We have successfully replaced vulnerable and managed consumer router with a highly secure enterprise-grade model. By using VLAN segmentation, next-generation firewalls, and strict SCLs, we have completely locked down hotel data and isolated guest traffic from business operations. Our dual SD1 setup eliminates branch downtime, guarantee 99.9% uptime for the central booking system. At the same time, we have modernized the property with high-speed Wi-Fi 6, seamless roaming, and green PoE power scheduling. This design centralizes all IT management at the main hotel, drastically cutting down troubleshooting costs and giving Heaven in a secure, scalable foundation that's fully ready for future expansion. Thank you everyone for listening.